Hello, hello. Welcome to today's STEAM Team Challenge. My name is Miss Julie and I am from the Warrenville Public Library in Warrenville, Illinois. This session of STEAM Team is all to do with balloons. I have three very fun activities, one that's indoor and two that are taking advantage of the very cold Chicagoland weather we have going on right now. So the first one we can look at has to do with how temperature impacts the size of your balloon. So first you're going to have to blow up one of your balloons, and then you're going to measure it. So you can measure it by using a tape measure around it, or another option could be to draw a line and marker and then measure that line, because what you'll find is if your balloon expands, gets bigger, or contracts, gets smaller, the size, the measurement of that line is also going to change. But whichever way you choose to measure, make sure to get a starting measurement for the balloon you blew up. Next, you're going to leave your balloon in very cold temperature. So that could be leaving it outside or in a freezer. Leave it there for about 30 minutes to really let the temperature get its effects in. You're going to bring it in after it's been outside in the cold, and you're going to measure it again the same way you did before. You're going to find whether it stayed the same size, if it got bigger, or if it got smaller. Then I'm going to ask you to leave it in your room, wherever you initially blew up your balloon, for another 30 minutes. So you're letting it get nice back and toasty back inside, and see if the measurements change again. See if after it warmed up, did it grow? Did it get smaller? Did it go back to its original size? So essentially with this experiment, we have blown up our balloon with gas. So we blew gas into this balloon, and even though we can't see it, it's actually all of these gas molecules bouncing around inside of here. And that's something called kinetic energy. So temperature changes the speed of kinetic energy. So as temperatures get lower and colder, kinetic energy gets slower. So the bouncing around gets slower. Then as temperatures get higher, so does kinetic energy. It gets higher, so it starts bouncing around faster. The question for you is, after it was out in the cold temperatures, so you had really low cold temperatures, did it get bigger or smaller, or did it stay the same size? And that's what I'm going to ask you to find out. Our other challenges are frozen balloons. So this one is pretty simple. All you're basically going to do is use however many balloons you want. You're going to fill them with water. You're going to want to stretch out your balloons first before you fill it up with water, and tie it off and put it either in a freezer or outside. Another option you could do is when you're filling up your balloon with water, you can add food coloring as well. And I'll let you know why in a minute. So after you have these frozen balloons, there's a lot of different opportunities for STEAM challenges at that point. You can test how fast ice can melt with or without salt. So that would mean having two frozen balloons. You would take the balloon part off, so you just have the frozen ice from inside the balloon. You could put it in two bowls, put salt on one, and leave the other one as it is. And you can find out how much faster ice melts with salt. Another idea, which you can do with however many balloons you want, is you can do an engineering challenge. So it kind of adds a little spice to your snow fort making or your snowman building. You can add in your frozen balloons. You can leave the balloons on, or especially if you took the food coloring in, you can take it off and just have those spheres of ice to use. And so if you had food coloring, they would be frozen and colored ice spheres, which are very cool looking. So those are your 2 challenges there. And then your last one's an indoor challenge. And this one I can actually demonstrate to you because it doesn't require us to wait for temperatures. But so you should have a water bottle with about a cup of vinegar inside. You should also have a balloon with about 2 to 3 scoops of baking soda. So this is a chemistry experiment. And what we're gonna do, you have the baking soda down here. You're going to expand the bottom here and wrap it around the top of your water bottle here. Do you see how I didn't let any of the baking soda go in yet? It's all dangling off to the side. And what's gonna happen is we're combining this baking soda and vinegar and creating a gas that's gonna blow up the balloon. We're creating carbon dioxide. So get a firm grip on the top here just to make sure it doesn't fly off. Lift up your balloon and watch as your balloon gets blown up. Pretty cool, huh? It's like a scientific magic trick. And it's gonna keep going until all of the gas has been created. Now I included a lot of different spin-up ideas for these experiments as well. For this one, you could try using different amounts of baking soda and vinegar, and you can also try cooling off the vinegar or heating it up to see if it changes the speed of the reaction at all as well. So lots of different possibilities there, but I hope you enjoy your balloon steam challenges. If you want to share any videos or pictures, you can send it to our Facebook account or you can send it to youthservices@warrenville.com. Thank you.